For this model, we wanted to determine if a business should invest in a new piece of equipment, and to do this we needed the operational costs of the current and proposed lines. With the operational costs and the capital costs of the new equipment, we can then calculate the payback period, which will then be used to support the investment decision. The process consists of two main stages, cutting and finishing. The current state runs across the top of the simulation. Here we can see material flow through the cutting and then finishing stages. The business is looking at replacing the cutting state with new equipment. Now if we stop the model and change the route, we are now sending the material through the new equipment and finishing stages, and we can see the material flow across the bottom of the model. We've created both the current and future state models in the same simulation environment to ensure we have a fair comparison. In this model we've set up some logic to retrieve relevant data at the end of the simulation run. This is dropped into a spreadsheet. The logic also does some calculations with the data and then creates a P&L for the operational costs. We have three spreadsheets in this model, one for process parameters, one for raw calculations, and the one we're interested in contains the operational P&L. The model has generated resource usage for each stage and converts this to a cost. This is done for the current and future states, and it's done per day and per tonne of product. The model calculates a potential sales revenue and then a gross margin, which is then used to calculate a payback period and a return on investment. So, has the model answered the question, should we buy this new piece of equipment? It's provided us with the operational costs of the current and proposed lines and calculated the payback period, and so overall it makes a positive financial argument for the investment.